Hello students, today you're going to learn section 2.3, polynomial functions of higher degree. Polynomial is when you have more than one algebraic term combined by adding and or subtracting. Standard form of a function is when you're ordering the polynomial from highest to lowest degree. Leading coefficient means the constant factor of the highest degree variable. If n is the highest degree, then n minus 1 represents the number of local extremas, meaning curves. N also represents the total number of solutions, whether it's real and imaginary, and this is what you call the fundamental theorem of algebra. So for example, if the highest degree is 4, you will have 4 possible solutions. They could be reals and imaginary. If the highest degree is 3, you'll have 3 possible solutions. Real or imaginary, or you could be all reals or real and imaginary. Leading coefficient and its variable degree determine the end behavior of the polynomial. So this is very important. So if we look at this equation, y equals x cubed plus 2x squared minus x plus 4, this is the highest degree here. So when we analyze this, this is the leading coefficient is 1 and the highest degree is 3. So when we list down the leading coefficient and the highest degree, what we're looking at is constant, the coefficient, and the highest degree. So when the leading coefficient is positive and the degree is odd, your end behavior is going to be a down-up end behavior. Okay, we're used to stating it in limit notation, and we'll do that later. But just to let you know, when you have a positive odd, you'll have a down-up end behavior. And this stated that the highest degree was 3. So if the highest degree is 3, that means we'll have 2 local extremas, 2 curves. So your function will look something like this. Something like that. So if this is your graph, the end behavior is down, the right behavior is up. But you need to know how to write this in limit notation, and we went over it in the earlier section. Okay, y equals negative 2x plus 4. We'll analyze this. So the leading coefficient is negative 2 and the degree is 1. So when you have a negative odd combination, negative leading coefficient, odd degree, your end behavior will always be an up-down end behavior. So left end up, right down, left end up, right end down. If you recall, this is an equation of a line which slope is negative, therefore the function is decreasing. So you'll have something like this. Well, if you look at the left end, the end behavior is up, right end, the end behavior is down. Okay, so let's take a look at this here. Y equals x squared minus 1 minus 20. So we're keying this term because this is the leading coefficient. It has the highest degree. Well, we know that the coefficient is 1, the highest degree is 2. So when you have a positive even, so positive coefficient, even exponent, your end behavior is going to be an up-up end behavior. Left end up, right end up. And we know, again, from even Algebra 1, even last year's math class, when the highest degree is 2, this is a parabola that opens upward. So if we look at this here, we have positive 1, the coefficient's 1, the degree is 2. We have a positive even combination, therefore the end behavior is up-up. when we have a quadratic, this quadratic opens up, the parabola opens up. And look at the left end behavior. It's up, right end behavior is up. But I want to make sure that you guys write this in limit notation. And again, we'll review that in the next example. All right, last combination. Again, let's identify this here. That's -3, 4. So this is your leading coefficient and the degree. Leading coefficient, degree. So the leading coefficient's negative and the degree is even. When you have a negative even combination, that means your end behavior is going to be a down-down end behavior. So it will look something like this. Left end down, right end down. And remember what I said earlier. If the highest degree is 4, we're going to have 3 curves. Actually, local extremas. Nickname is curve. So we have 1, 2, 3 local extremas. Highest degree is 2. The number of local extremas you'll have is 1 less than 2, which is 1. The highest degree here is 1. So if the highest degree here is 1, that means the number of curves or local extremas you're going to have is 0. So there are no curves here. And again, if you look at this, the highest degree is 3. We have 2 curves, or you can say 2 local extremas. Okay, so let's work on some examples. Some examples are going to be, the instructions for the examples are going to be, write the polynomial in standard form. That means highest degree to lowest degree. Find the number of local extremas and its location. State the end behavior in limit notation without graphing. Okay, so you got to do this without graphing, but we could check. So this says f of x equals 2x squared minus 11x plus x cubed minus 12. We need to put this in standard form. Standard form means highest degree to lowest degree. So that's why I rewrote it as x cubed plus 2x squared minus 11x minus 12. This is now in standard form. So we're done with standard form. Next, find the number of local extremas. Well, if the highest degree is 2, that means there's only going to be, if the highest degree is 3, that means there's only going to be 2 local extremas. Okay, so we have 2 local extremas. We can graph this. So let's just clear this out. Y equals, clear that. It's x cubed plus 2x squared minus 11x minus 12. Let's graph. Okay, so you could see there's 2 local extremas. And I said state the number of local extremas without graphing, so we did. But we do have to find the value of the local extrema. So there's a local maximum and a local minimum. And again, just to show you real quick how to do that, you go second calculate. You want to find, let's find the maximum. So here's a local maximum. Okay, so we're going to surround it. Left end, right end, and there is our local extrema. Okay, so that's at negative 2.694, comma 12.597. And again, to find the local minimum, you're going to go second trace. You're going to find minimum. So we are going to surround the local minimum, left bound, right bound, and there it is, negative 1.361, comma negative 20.745. So that's your local max, your local min. And again, to find this, to find the end behavior, we're looking at the leading coefficient. So we have again, let us put this in standard form, highest degree first. So 4, 3, 2, 1, 0. Now just by looking at this, look at the leading coefficient and its degree. We have a positive even. If it's a positive even, it's going to be an up end behavior. And if the highest degree is 4, that means there's 3 curves, 3 local extremas. And again, you can just find that with your graphing calculator. Okay, so to do that with your graphing calculator, substitute 2x to the 4th plus 2x cubed minus 22x squared minus 18x. Oops. Notice I forgot to hit the right arrow, so that would be wrong. So let me clear that again. So we have 2x to the 4th, right arrow, plus 2x cubed, right arrow, minus 22x squared, minus 18x plus 55. Okay, so again, look at, there are 3 local extremas. Look at the end behavior. Up, left end, up, right end. And again, we can figure that out by hitting second trace. So to state this in limit notation, this is the limit of f of x as x approaches negative infinity. Left end is up, so that's positive infinity. The limit of, that's g of x. The limit of g of x as x approaches positive infinity, the y value is positive infinity. And again, here's to verify about what we wrote earlier, just by looking at combinations of leading coefficient and degree. Left end up, right end up. So left end is approaching positive infinity, right end is approaching positive infinity. All right, last topic to know. Multiplicity is a repeating zero where the x-intercept of a polynomial function is a relative extrema, which is the vertex. So for example, this is a parabola and it opens upward. Let's graph this. We'll have x squared minus 6x plus 9 graph. Okay, so that means that there we have a repeating zero. The repeating zero is going to be here because if you look at the local extrema, it's actually a vertex that touches the x-axis. So the local extrema is the vertex that is an x-intercept. So when the vertex is the x-intercept, you have repeating zeros, which means it's a multiple of the same solution. So the multiple zero here is going to be x equals 3. So it's x equals 3 and x equals 3. If you were to do this algebraically, you'll notice that this is going to be x minus 3 times x minus 3. So x equals 3 is your multiple 0. They call this a multiplicity of 2 at x equals 3. All right, and the same can be said here. Let's go to y equals, we'll clear this. That's 4x to the 4th minus 8x cubed minus 19x squared plus 23. Oops. Let me clear that one more time. Okay. I inputted in correctly. 4x to the 4th minus 8x cubed, hit right arrow, minus 19x squared plus 23x minus 6. Okay, so if the highest degree is 4, there should be 4 solutions, a combination of reals or imaginaries. But you could see that the graph only crosses the x-axis 3 times. Okay, so, but we should have 4 solutions. Well, here it is. I'm zooming in. There. So this local max is a vertex on the x-axis. So if the local extrema is an x-intercept, that means this repeats twice. So x equals, let's see, x equals -2, x equals 0.5, x equals 0.5, and x equals 3. So there are 4 solutions here, but this has a multiplicity of 2, meaning it repeats twice. Because again, when a local extrema is an x-intercept, it's a repeating 0. They call it a multiplicity because there's more than one of the same x-intercept. And we've noticed that if this is x to the 4th, we have 3 curves. 1, 2, 3. Positive even, we also know that end behavior is up, up. Okay, that's it for now. Have a good day.